Hello and welcome to this introductory video talk discussing the AQA Physics A-level that's offered at Old Swinford Hospital Sixth Form. I'm going to pass over to the subject lead for physics, Mr. Askins, who's going to talk a little bit more about what the course entails.
Physics is taught by myself, Mr. Askins, and Mr. Hodgson. In Year 12, we cover a range of topics. Some you recognise from GCSE, whilst others may be new to you. Particles and radiation is one of those new topics and deals with the particles that make up the atom, and indeed the particles that protons and neutrons are made of. It also looks at how these particles interact, as well as scratching the surface of the evidence that tells us that particles can behave like waves, as well as waves can behave like particles. Tying into this topic, the physics department has taken regular trips to Geneva, including a visit to CERN and its Large Hadron Collider, as well as to Einstein's house in the Swiss capital Bern. These trips have been hugely rewarding for those that participate. In the waves and optics topic, we explore more deeply into the nature of all types of waves, with an emphasis on a special type called stationary waves. We then delve further into wave properties, particularly refraction, diffraction and superposition. The mechanics topic is similar to that covered in the maths at A level, so students taking both subjects get a thorough understanding of it. We look at forces, moments, velocity and acceleration, Newton's laws and momentum in much greater detail than a GCSE. The materials topic focuses on stretching materials to see how they behave and gives an insight into engineering for those interested in that as a future career. Year 12 work can also with electricity, where we look at series parallel circuits, resistance and the properties of cells. Throughout the year, lots of practical work is undertaken, including 6 required practicals where student skills are assessed. In Year 13, we return to mechanics with circular motion and simple harmonic motion, which deal with rotating objects and objects that have repeated oscillations. These are tied to real-life examples of engineering. In thermal physics, we take ideas from GCSE further and cover specific heat capacity and latent heat, as well as the kinetic theory of gases, which deals with how molecular movements give the gas its properties. The fields topic looks at 3 key areas: gravitational fields, electric fields and magnetic fields. The magnetic field section is particularly relevant to understanding the working of electric motors and generators. In nuclear physics, we take GCSE much further, with particular emphasis on fission and fusion. The course is completed by doing the turning points optional topic, where we look at key physics theory developments and how they changed our view of the world around us. Of particular interest is our work on Einstein's theory of relativity, his special theory of relativity. For example, the twins paradox. Google it. We hope all of our students enjoy their physics lessons and feel supported throughout their time at Old Swinford.
You've heard from Mr. Askins there. The department comprises of himself and Mr. Hodgson, and in terms of the unique features of the department, well, you've got the traditional CERN trip, which unfortunately had to be cancelled this year because of the COVID-19 crisis. That's a regular fixture on the calendar. There's also weekly support sessions available for Physics A-level students after school, and students are welcome to drop in at any lunchtime as well. So combined with the fact that there's excellent results over time, so last year 8 out of 23 students that did physics achieved an A-star and A grade, and the fact that every single year we have at least one student that chooses to study physics at degree level showcases the supporting nature of the department. To study physics at A-level, you need to meet the school's minimum entry requirements, and then there's a few other minimum entry requirements to study the subject. You need as a minimum to have had a grade 5 in your maths and in your English language, and you must have a grade 6 in physics and either grade 6 in one other science or a double grade 6 in your double science qualification. So it can be quite complicated, so just make sure that you understand exactly what you need in order to study the Physics A-level course. The things that we're really looking for is to have that strong mathematical skills. There's a big overlap between mechanics as a module for maths and the physics component. So students that tend to combine maths with physics find that to be relatively straightforward, and usually what we see is students that do physics also will do maths. You must be able to work in a team because the classes are relatively small. There is a lot of questioning going back and forward between students and with the teachers as well. So understanding how to solve a problem as a group is something that you'll look at A-level standard. And you must have an inquiring mind. Physics is the study of all those things that are around us, those hidden forces, and to be able to try and think about those questions that have plagued the minds of physicists for the past thousands of years. Physics is a subject which is seen very highly by institutions and employers. It used to be part of that list that we call facilitating subjects, but it's not really something that we use anymore, facilitating subjects. It's a requirement if you're looking to do engineering or physical sciences. So if you're wanting to do engineering, and it's not necessarily every single branch of engineering, but realistically most engineering degree courses will say that physics is a requirement alongside maths. If you're looking to do a scientific based course, there is an advantage to doing physics with it. So for example, if you're wanting to do medicine as a course, having a good understanding of physics will help you understand the physical chemistry component of your chemistry A-level. So it is something that is advantageous to have. For any other course, A-level physics, as I've said, is treated as a serious academic qualification. It's treated as something that showcases lots of different skill sets, not just mathematical skills, but also ability to solve further problems, apply that knowledge, and also writing in more extensive ways. So you can use physics as an A-level to go into further academic research, but you can also use it for computing, optoelectronics, telecommunications, motor vehicle technology, power generation, medical physics, meteorology, medicine, finance, marketing, business management, teaching. It's a subject that you can use for absolutely anything. And you can see last year, these are 7 students that did A-level physics, and you can see the variety of different routes that they've gone into. But you can see what's a common feature amongst these students is that physics is combined with mathematics, and to do physics and maths together is a sensible combination. You can also see other popular subjects that you can combine physics with are another science, so biology and chemistry. Geography is also something that lends itself well as a humanities-based subject that has scientific elements to it. So for the summer, what we want you to do is we want you to do the essential bridging tasks that have been set by the department, and then there's some expected tasks. So if you're serious about your A-level studies in physics, you can consolidate some of the things that you've looked at for GCSE level, and you can broaden your subject horizons as well. So the first thing that we would suggest that you do to consolidate your GCSE material is log on to Seneca, complete the Physics AQA A-level preparation module. So that is a specific module designed for people making that jump from GCSE to A-level study to do the specification that you will be doing. So it's worth your time going on there and having a look. Mr. Askins as well has set a series of different tasks that you might want to have a look at that will get you used to a bit of independent research that you'll need to do for A-level standard, but it will ask you to make some notes on some difficult topics that you would have looked at for GCSE level, but really this is something that is going to be making up a huge component of your A-level study. So if you've done this at GCSE, this is now to the next level. He would like you to do this using the Cornell note system. Now, Cornell note system is something that you'll hear more about at A-level standard, but you can have a bit of a look as to what that entails. It's a quick way of making notes, it's a really organised way of making notes, and because lessons will go through quite a bit of content at A-level, it's important that you have those skill sets. So it's something that we will teach you in September, but it's also something that you can do now. In terms of broadening your subject horizons, the suggestions from Mr. Askins are that you listen to the BBC Radio 4 podcast, The Infinite Monkey Cage. If you're combining physics with biology and chemistry, that's an excellent podcast for all of the scientific-based subjects, because essentially it's taking a academic and a humorous take on some of the key scientific issues of the day. So it's Brian Cox, obviously very, very famous physicist, and the comedian Robin Ince. So recommend listening to that. You can listen to them all on BBC Sounds. The Feynman, so the Richard Feynman lectures on physics are available online as well. Such a seminal physicist that you should really be aware of and note his impact. And you can actually find all of his lectures available online. So if you type in the Feynman lectures on physics into Google, you'll be able to have a look at them. Finally, the things that are essential. So these are the things that you must do. You must do the middle task, and you must choose 2 of the other tasks from around the outside. You'll notice that they're quite similar to the tasks that Mr. Askins has said to take in the Cornell method of note taking. But the middle task is the one that you really have to have a go at. So that link that's on the screen there, and it's part of the bridging tasks that have been sent out. What we'd like you to do is we'd like you to take a specific set of notes and practice exercises that base on the dealing of some quite foundation topics within physics. So have a look at the task, read through the notes, have a go at the exercises, as many as you can, and bring them in for September so that your teachers can have a look at. The other tasks which are around the outside, so you can look at Newton's laws of motion. They're the fundamental laws that you need to know about. Use that website, make notes on that particular on Newton's laws of motion so that they're almost embedded in your mind. Produce a timeline for the discovery of particles from the atom to now. So we're looking at the work of physicists over time. So we're looking at how the understanding of particles has changed over particularly the past 100 years. Write an essay about the changing theories of light over time. So try and use, as part of your notes, that timeline to go through detail on key concepts, experiments, scientists as well. Find 5 common physics misconceptions on YouTube and ask 5 to 10 people their understanding. So write a brief scientific report of your findings. CERN, as we've mentioned already, is a regular feature of the OSH calendar, and it's the largest collaborative science experiment ever undertaken. Have a look on the CERN website, which is on this particular page as well, and write a 1-page report on what CERN does. CERN is an important institution to be aware of for your studies. And finally, PhET is an online physics simulation that you can use to complete some simple experiments online. So have a go, open up the resistance of a wire simulation, conduct a simple experiment, make a 1-page summary of the experiment and your findings, and you can have a go at a number of different ones on that website. If you've got any questions from this, if you contact either Mr. Askins or myself, and what we'd suggest that you do before the next video starts is that you have a look at some of those things that we've mentioned, like the Feynman lectures, some of the links that you've got here. Make sure that you've noted them down, and you can start having a look around them before the next video begins. Thanks very much for listening and watching.